We've had some technical issue, as you could see, because we couldn't see actually the presentations in the Google Drive folder we just shared with you, so we had to solve it somehow, but we've managed to do it, and now it is the time to actually start the closing ceremony. But right before we would jump into the first pitch, I would like to summarize the next the next hour, but yes, originally I've made this presentation when I wasn't expect any delay, so let's say that we start now. The pitches will happen within 1 hour, hopefully. Each team will have 4 minutes to pitch, and the audience, so the teams as well, can ask questions from the teams. But since we are a little bit over the originally planned time, we will only accept 1 question for each team, okay? And after we had all of the pitches, all of the 8 pitches, we are going to open the finalist voting. You will have to go to the Junction app. We will send the mentors and the jury an email with a voting link. So you will get it around, I think, maybe you've already got it, but yes, you will get an email for it, and you will have to make your vote. Each people can vote for 1 team from the 8 finalist teams, okay? You can change your vote, but as soon as we close the voting, the vote that you made the last time will be counted. So, and during the voting, we will have 10 minutes to vote. We will announce the winners of the challenges and also the winner of the CraftHub game, where you could win 2 tickets for the conference next week for the Compass Tech Summit. And then we will announce the grand winner as well. And just before you would leave, please come to the stage, because we will want to make a group photo with you. So do not leave right then, but wait a little bit. So I think that we can start, and I think that we will have 1 team who will join online and who will present online. So I think that we could start with them. So I would like to ask that the streamer guy to start with the Crash Guard presentation. And they will hopefully join us on the screen, or at least we will see their presentation. So let's see the first software finalist team, Crash Guard, and yes, can we just join them? A few minutes, but hopefully maybe we'll manage to do this. Do we have the team in the meeting? Yes. Actually, they are here as far as I know, but they haven't prepared with the pitch because I think they thought that they couldn't get into the finals. Am I right? No? So the master of the pitches couldn't be here this time. Do we have the pitcher in the meeting? Okay, if not, I think that we can just move on to the originally first team, the AI set team. They also prepared a project for the software challenge. So let's see, who is the AI set team? I would like to ask them to the stage, so please come, and please put the AI set presentation on the screen now. I should have that thing that judges use, you know, the hammer. Ha!
Okay, Hello everyone, we are the All Set team. We did the software part. We used processing and coded it in Python. We are a team of four, but only two of us could attend offline. So we try to create a safety feature designed to assist in preventing potential collisions on the road. So our system uses algorithms to constantly monitor the vehicle surroundings and assess potential risk. For example, when an object is in front of the car, or even if it's further, we created we created two radius. The green one is the brake radius. It stands for when we couldn't stop before the collision. So in this case, we used we wanted to use evasion. For example, our software will turn the wheel to the left or right to avoid the collision, and then recalculate the new environment. But if the relevant object is only in the yellow circle outside of the green, we can use the brake to stop before the collision. We also visualize the estimated the future path depending on our velocity and the yaw rate. Also, we try to visualize the movement of the potential target, so we can recalculate our future path based on their movement. So we try to sort the unnecessary information. For example, when the data set contained a lot of zero values after valid distances and speed, we remove them from the data because it created a coherence which just messed our program up. And after we remove these data, we could calculate the estimated path of the object, and we could find the potential object. For example, we always choose the closest object to our vehicle. Yes. We visualize the situation. The red dot means the potential target, and with the yaw rate, we could calculate our future path. And for example, if the potential target reached our radius, so we recalculated the path. We also tracked the other objects that were out of the radius, because if we will make a turn, it is possible that we will hit that object. Okay. Our main object was to not hit the object and avoid collision. Thank you.
Thank you, guys. I know, no, don't not go anywhere. Hey, come back. Yeah. So is it your first time on the stage? On a stage? You were a little bit excited. Okay. Don't worry. Being first is always hard. So let's see if we have any questions, maybe from the mentors, the juries, or from the teams. Oh, there is a question. Yeah.
So any other idea instead of braking? Yes, we couldn't finish the last part, but our other option was to check both sides of the object and choose which path would be the safer one. So where we won't find another object that could be our next potential target. Yes, we try to steer the wheel.
I told you just one question, so thank you guys. Let's see the next team. And hopefully, yes, a huge applause to them. You've just opened the pitches. Great job, guys. So let's see the second team, the Crash Guard. And as I heard, they are here, but we had some sound issue previously. But let's see them on the screen.
Okay, thank you very much. So, automobile crashes have historically been one of the leading causes of deaths ever since the invention of cars. It comes as no surprise, since humans face complex, difficult driving situations on a daily basis. Automatic and emergency brake systems have proven to be one of the most influential safety systems in today's cars, so much so that every car sold after 2024 must have this system on board. This system is capable of stopping the vehicle based on sensor readings without the need for human action. To create the next generation of intelligent AAB systems, we present to you CrashGuard, a 3-layer AAB system which contains a sensing layer capable of displaying real-world sensory information, coupled with a detection layer highlighting potential sources of danger, and a hybrid deep reinforcement learning-based PID controller to create an accurate and robust safeguard for our travel. CrashGuard also combines different modalities of warning signals before activating AAB, such as tactile driving wheels, flashing lights, sound signals, to ensure a quick reaction time and accessibility for everyone involved. The sensing and perception layer displays the sensory information in a 2D environment, which serves as a physical simulation background for our controller. The perception layer also displays the closest region of interest in a different color, ensuring easy evaluation of the controller. Our control of this AAB system relies on a deep reinforcement learning-based PID controller, combining the ability of deep reinforcement learning to handle high-dimensional, probabilistic stochastic situations alongside the stability of traditional control algorithms. This approach has 4 main advantages. The most important, that it is data-driven, free of any models, therefore capable of handling situations where modeling is a near impossible task. Number 2, it is capable of adapting to the driver's driving style and risk tolerance. It also supports sensor fusion capabilities, easily handling higher dimensionality data collected from different sensors, while also having the ability to make connections between sensory information through the use of an encoder network. This training, or this control framework, also provides a cheap and effective training for a controller through the use of physical simulations, which can then be transferred to real world based on minimal real-life sensory readings. This approach also makes use of the limited data given by you guys by using it as a reference trajectory for physical simulations, which allows us to generate our own independent data for the training of the control system. Our system is capable of avoiding collisions by having the ability to not only upright brakes, but to also swerve away from incoming sources of danger. This is further emphasized by the behavior coded into the controller, which promotes the use of smooth changes in speed and turning angle, while also maximizing the ability to avoid crashes. In our future directions, we would also like to incorporate the perception layers feature vectors into this training loop, and also as an added feature, the incorporation of the warning signals into the controller's behavior as well. Therefore, with CrashGuard, we aim to serve it as a new way of combining AI with the reliability of traditional control to ensure that everyone gets back home safely. Thank you very much. Thank you very much. And this was our presentations. Oh, sorry, I can't really hear you. Can you give Agata the question and she can maybe like... Yes, please. Yes, so the control algorithm has two parts. The first one is the decision-making brain of the algorithm, which is done by reinforcement learning. But since it's a neural network, it sort of has like a black box type of system, and it can also output really different values. So as to give the system sort of resilience against this output noise, PID controller is used to mitigate the effect of these outlier values. You're welcome. Thank you very much.
Okay. Crash hashtag like a Bosch. Crash hashtag. No. Which team? Crashcraft. Okay. Come.
Hey, we are Team Crashcraft. I'm Zoli. Thank you for your patience. I hope you think it was worth it. Our task was also implementing a collision detection software. Our software was consist of 3 main steps. First was that. First, we parse the data from a CSV file, and after that, on that data, we run simulations, and the results of the simulations are displayed on the screen in a 3D displayer. And I'm going to the details about the simulation running part. First, we convert these data to the word coordinates, because it wasn't in word coordinates. And after that, we did the path detection. We used our weighted sliding window function. It was quite good, we think that. And after that, we used the path and did the collision detection. And where we detected collisions, we diagnosed the scenarios. We have 3 given scenarios, and we had to decide what scenarios it could be. And after that, we diagnosed the scenario. We did some action. We calculate an action like hang a horn or blink a headlight. And I will pass the word to János.
Okay, so our solution is a web-based solution. We made it with React and using 3JS. We only had one data set provided by Bosch, but we tried to detect all the 3 kind of scenarios. So we created 2 other data sets, and we even had a file upload thing where you can upload a new data set and it would run the simulation on that. And yeah, this is our simulation viewer UI. We display the objects, the car, the predicted paths, and on the right side, we display the information about the speed of the car, the braking force needed to stop the car before the accident. We detect the scenario type. This is actually implemented in code, so we are really detecting the 3 kinds of scenarios, and we provide some information about the tracked objects and their positions in the world. You can even use the playback feature like on a YouTube video, and it will display what you would expect. You can change the playback speed and everything, and you also have a top-down view of the whole environment. Yeah, this is what Zoltán told about. So we predict the trajectory of the objects and the vehicles, and we try to find the collision point and do the appropriate action to prevent the collision. And also during the development of this challenge, we thought that this platform could be very useful for other developers who are trying to test their code, their collision avoidance code. So we propose to make an online platform where everybody can test their own solutions, and using real data sets, they can run simulations. And we even made a prototype for like a low-code environment where you can set up a new strategy and simulation. So that's all. We are CrashCraft. Yeah. So there are quite a few teams with the Crash in their name. So we are CrashCraft. It's like CraftHub. So you can remember us when voting. And you can try the application. So like it's deployed and it's running. Yeah, it looks better on mobile.
Okay. Are you excited? A bit. Okay. Do we have any questions? Yes.
Yes, we came up with a pretty clever solution, what just Zoltán tried to talk about a bit. So we actually calculate the collision point and also account for the time intersection to take. So we calculate how much time does it take to get to the intersection, and if it's under a threshold, and also the threshold is calculated based on the car speed. So if under the threshold, then we say it will be it can be a crash or a collision, and if it's not, then we filter out those invalid detections. I hope I answered the question well. Any other questions? Just one question. Sorry. Thank you very much.
No problem. Thank you, guys. Okay, and let's see the last team from the software challenge, the Crash Like a Bosch team. So please come to the stage. There is the presenter, and you will have 4 minutes, guys.
Hi everyone, we are Crash Like a Bosch, and we designed a collision avoidance system for you, and we're gonna present it to you today.
we have created a demo to demonstrate the basic capabilities of the system. Firstly, we can issue warnings based on the brake distance of our vehicle. Secondly, we do path intersection detection, which means that we try to extrapolate the movement of the parties using line and circle equations and warn when they are about to collide. And thirdly, we have done the situation classification task, which was the second task of the challenge.
We also created a web-based platform for visualizing the process datasets. We have a nice way to easily switch between different datasets and also reuse already processed ones. We have some fancy settings to bother with, and also a viewport where we are visualizing not just the main car but the objects, aka pedestrians, on the detection zone of the car, and visualizing also the road based on the velocity and rotation of the car. As you can see, we have different colored pedestrians. The default one is yellow, which turns to blue when it crosses the way of the car, and it turns to pink when it becomes possible fatal. So we wanted to demo this, but we can't, unfortunately. Also, we have the events part where we are logging the classified situation and some other useful data too.
I'm kind of sad we couldn't show you a live demo because it actually works really well. But yeah, I will talk about the future of this now. So one of our future plans, which I think was the most significant, was to implement more things that we can avoid collisions with. One of them was to look out for cars in our field of view, which cover a lot of space, and if they start acting cautiously, our car, so like the main vehicle, acts the same. So if the car next to us blocked like a pedestrian which you couldn't see, we also won't hit it. Yeah. Also, one of the future things was to improve on detecting these objects from images, because I think that's the technology that can improve the most. And I wrote one example, mitigating the bias of centered objects in common data sets, which basically means that we use data sets where objects are not only placed in the center for detecting, but on the edges. So the model works more confidently, and it also has a lower latency. Thank you.
Question? No, not this time. Anyone else? Okay. Thank you, guys. I think you just made a really great job, so that's why they couldn't ask any questions. No, thank you, guys. We should move on to the next team. So, yes, you can leave the stage now. And as far as I know, the jury of the software challenge hasn't decided the challenge winner yet. So please do so in the next, I don't know, like 30 minutes. And let's move on to the hardware challenge projects. And with the infraline drill body presentation, now we can present it for you. So here is the presenter. You will have 4 minutes.
Hey guys, this is the team of infraline drill body. My two friends are online. They couldn't join. So everyone who has ever used the drill has found two problems. One is that they can't measure exactly the length of the hole they want to drill, and the other is the angle is not aligned. So we're here to solve both of these big problems. So there are, of course, some existing solutions, such as these mechanical and visual aids, but they are so cumbersome, they're boring, and it's just not fun to use. Who wants to carry on this useless stuff with themselves in their bag? And of course, we have a solution for this with the infrared laser extension. So this is very convenient to use. It's really small. You just put on the drill head and then put it in place of the drill head. And then at the end of it, you put the regular drill head so you can use it normally. It's accurate, no more eyeballing, very user-friendly. It's mobile. You can put it on your drill and leave it on there. And it's just really fun to use. So the magic features of how it works is that there are 3 lasers which can tell you exactly the depth of the hole you want to drill and also the angle. So you can keep it orthogonal to the surface at all times. So the first part is the triple lasers. You have kind of a cube on top of the drill head, this extension, which you can spin around, and then it will change the angle of the drill, which you can use to also measure really tight spaces where these existing solutions don't exactly work well on. The second one is the distance calculation. This is pretty easy to see how it works. So the 3 lasers can measure the distance from a 0 point, and we just calculate it. And then we know the depth of the hole we want to drill. And the last one is the angle measurement. So this is basically makes sure that the surface we are drilling is always orthogonal to us. And of course, this doesn't use accelerometers or anything like that. So we can measure even some weird surfaces like this, and it works every time. And all around, it's just a really good user-friendly solution, and it opens some big customer segments because many of these people who don't have confidence to use these tools or they don't trust themselves to drill orthogonally can just use this really easy to install extension and then have fun with the drill body. So thanks for your attention.
Thank you. I cannot see the jury from the hardware challenge. Oh, they are over there. Do you have any questions to the team? But probably we won't hear it. Okay, there is another question. He raised his hands firstly, so.
So we have a really big battery actually. So it has 6 AA batteries because you couldn't find a better solution. But basically the extension, you can just change the battery inside it. You take it off, put in the new batteries, and then install it again. So it's different. It's completely different battery from the one the drill uses. Yes, a bit. So we're still working on using like these smaller cell batteries, but it can be done. It's just a prototype at this point, so yeah.
Thanks. If you have any other questions, you can reach out to him, I think, among the audience. So thank you very much. And let's see the second project from the hardware challenge. And the team's name is, I'm not sure if it's Screw It or Screw IT. You can tell me, so please come to the stage and tell us about your drill or screwdriver idea.
Welcome everyone. I hope you are enjoying this beautiful afternoon with all these speeches. We are the team Screw It, and we take care of your and your tools' health. On the next page, there will be a little bit of disturbing picture, but this is the reality. People who are constantly put out to vibrations, vibrations can cause serious health damages, and this is called hand-arm vibration syndrome, which is irreversible, and it can't be healed. And probably there is around 200 million people in Earth living with this disease. And also, when we were working around this vibration stuff, we also found out that vibrations are constantly reducing the structural integrity of our tools and cause serious damage while not just damaging your hand, but your tool is going corrupt too. While working on this problem, we also managed to enhance our battery life and also found a solution to align our drill to be able to precisely drill. Our solution consists of vibration data analyzing, and we use two methods. First, we use haptic motors on all three axes, where we can countermeasure the vibrations, and we measure it with an accelerometer, and also we can, because we know all the data, we can optimize the power of the drill, and we are able to reduce the vibration with that too, because we are modulating our RPM or our torque. For the aligning tool, we use a gyroscope and an OLED display, and also because of the optimal RPM and torque assistant, we can reduce serious battery time, where we earn a lot of money and a lot of time for the factories. Our solution also is based on a neural network. We send the data through Wi-Fi to a CSV file into a database, where it processes all the data and sends back the processed matrices into the drill, and we have a whole electronic background for it with microcontrollers and sensors. And as I mentioned earlier, I didn't mention it earlier, we communicate through I2C, and that's enough with the electronics, I think. We have a detailed description in our datasheet. Let's talk about business. We have, as I mentioned it earlier, we have a lot of people in this disease that can generate Hungarian size GDP yearly. Also, the total attainable market is around more than 7 billion yearly, and we are targeting automotive industry, manufacturing, and military development and healthcare also, mostly in Pacific Asian sector and Europe and North America. Our product costs €35, and we can get a pretty reasonable €30 price on it, and we can generate a year revenue of 4 to 6.7 million euro. Let's go to the next slide. This was our team from 3 different universities, and we are really thank you for your attention.
Thank you, guys. Let's see if there is any question. There it is.
We just have to counter it, and it's like small vibrations, right? It depends on the toughness of the material, and all haptic motors can countermeasure those kind of vibrations. Yeah.
Okay. If you have any other questions, look for the guys. They will be here at least until the end of the closing ceremony. So thank you, guys. A huge applause to them as well. And as far as now we still have 2 teams. So the next team will be the Bosch screwdriver, driver, right? I'm always a little bit confused about that. 4 minutes, you've prepared with notes, great. Good luck, the stage is yours.
Hello there, everyone. Yeah, we definitely did know that we were setting the name when we put in Bosch screwdriver, and yeah, that's our name. So we have decided to create a screwdriver that has torque control in it and uses RFID technology to set different torque profiles that were preset by manufacturers. So our main idea is that in many like small businesses and like small manufacturing units, they need to assemble a lot of different units, and the workers there do not have the best qualifications to work on these sort of things. So they would have at their workstation different RFID chips on their table, and they could just touch the screwdriver to the different RFID chips, which would set a preset profile that was like described by the manufacturer that limits the torque of the screwdriver, so that there will be less errors made, and the process of creating these products will be faster. Yeah. We mostly see it used in electronics and in places where total automatization is unnecessary, but it is very important to have precision.
Thanks. So now after you know what we are talking about, let's dive into the actual torque system. So how we managed to to be able to control the torque automatically. This system is integrated in our design, and we measure the voltage of our motor with conducted resistor. So as we know the nominal resistance of our motor, we could calculate its current. About our motor, let's talk about its characteristics. We know that it can give its max current is 7.5 ampere and its maximum torque is 4.5 newton meters. And as we know that there's a linear connection between the two, we could calculate the equation between the two, which you could see there, that the torque is equals 1.67 times the current. So, and how exactly we managed to solve the current control? We used 4 parallel linked double edge bridges, and you could see it pictured there. Namely, these are L298Ls, and you could ask why we used 4 of them, not just to design one, because it's much more easier to integrate into our system, and it's much more cheaper than to develop a whole new system for it. And yeah, and why do we need 4 of them? Because one can only support 2 amperes of current, and if we link parallel 4 of them, then they could support the whole system. Yeah, and about the, so if we limit the current, we will limit the torque with it, and this is our main idea. And we also included an adaptively controlled control, which is done by the control theory. Thanks.
We also made a lot of research on what part of the machine, how much it will cost, but don't worry, we don't really like either watching long paragraphs, so, but it was needed to write the exact curves that can project how many units have to be produced until the investment is zero out. So after that point, the company just will have profit on every single model. And in the case of screwdrivers, we don't even need to change the basic houses because it can be fitted into the existing models. And the calibration units are create a whole new market for RFID chip setting for Bosch.
So we tried to bring our ideas to life, and we made a prototype. basically the heart of our prototype is Arduino Nano every board and Joy IT SBC RFID RC522. We also included 2 LEDs, and these are for visualizing the output of the system. You can see it here. And you can play with it.
Closing sentence.
No, we don't. Like, that's it.
Thanks for
Questions? Or you try it and then you will have questions, right? Okay. Look for the guys. They will answer all of your questions. You can try that tool over there. So thank you. Good luck. And let's move on to the last team, which is Project Furpang. It's like a Hungarian joke. I mean the Furfang part. So let's see the team. Where is the team? They are coming. Take your time. I will be here. Okay. There is the presenter. And you have 4 minutes strictly, okay?
Hello, we are Project Furfang. Our team is Laci, Artur, Bence, and me, Ákos, and we also worked on the screwdriver project. Basically, we realized drilling is not that easy of a task if you really think about it. And we tried to really squeeze a lot of functions into our device. And we actually had really big success with the integration. As you can see, here is our little beast. It kind of looks like a snail, if you ask me. But it actually works. The battery is dying right now, but you will be able to check it out later. We walked around the problem of how we can improve a screwdriver, and we choose 3 points of view to improve the actual device. For an actual home user, for a do-it-yourself person, the most important things are the depth measurement, the angle of the drill on impact. And these are relatively easy tasks to solve with a gyroscope and ultrasound distance sensor. But with some clever data processing, we can actually detect slit slipping. If you hold the drill not in the right orientation compared to the screw, it can slip. It can damage the tip of the screwdriver. And if you have the right tool, it can actually detect that. And it can actually stop you from destroying the screw in the wall, which can actually spare you a lot of headache when you are trying to take that screw out of the wall. We try to implement some other functions like direction change with some twisting motions. So we had some luck with the thing. If we hold the thing and we twist it, it screws in that way. And if you hold and twist the other way, it changes directions. So it actually was really cool to play with it when we developed it. Yes, but from an industrial point of view, it's much more important to measure how the drill is actually doing. For example, if you use your drill daily and for heavy-duty tasks, the actual physical body of the drill and the tools, tips, the edge of the blade will dull. You can actually measure that. For example, we can measure the torque on the motor, not with current, but with the twist of the handle. And it can detect the state of the machine. And a very important thing, we have a Wi-Fi in the unit, and all the health and maintenance data can be uploaded to the cloud, which can be used both by the manufacturer and the user to maintain the actual tools in the arsenal of a company.
Yeah, so just one moment about our business model. We calculated that all the drill market worldwide costs about $4 billion US dollar. So it's quite a big market, and Bosch is the third biggest company on it. So with this improvement, like we just counted on Kickstarter, all the users or every third user will or want to buy a more improved stuff like this. And with our improvement, which cost only $14, we just calculated it, and of course some research costs, we can get $25 profit pro tools. So it could be a quite big market for this improvement. Thank you.
Thank you, guys. Any questions to the team? Okay, then thank you very much. You can get back to your seats. And now the exciting part has arrived, since we are opening the finalist voting right now. And do you, is it enough, like 5 minutes to vote? What do you say? 5 minutes. Okay, then we will close exactly at 6 p.m. the voting, okay? 6 p.m., okay? And during that, I would like to ask István, a mentor and jury from the Hardware Challenge, to make a special announcement.
Okay, hello guys, it's me again. I'd just like to see, raise your hands if you have taken the Hardware Challenge. Okay, much better ratio than the beginning. Okay, so it was a rough 24 hours, so I have seen all your works, and these were really good. And yeah, we have a special announcement. Everyone from the Hardware Challenge is a winner right now, because Bosch decided that you can keep the drills, the screwdrivers, and the microcontrollers, and the sensors, and so on. Yes, but we want back the screwdrivers, the multimeters, the soldering irons. So please, these parts we are needing back, but you can take home the screwdrivers and anything that you have already worked on as a gift from Bosch. So it's your present. And good luck to the finalists. Thank you.
Thank you, István. Okay, so we are still having 4 minutes. And I can see that you are making your votes, and there is a question. Let's hear it. Okay, so you have to go to the Junction app, and on the dashboard, I mean on the left side of the Junction app, you will find a final voting option like we had for the dashboard and the team and other stuffs. So you have to open that 3 vertical lines. No, not vertical, horizontal lines on the left side of the Junction app. And if you open it, then you will find a final voting part. And then you can see the 8 finalist teams. I don't know if there's anyone who could actually do that, can help the guys, or you just find that? Not yet? Excuse me? One vote for each person, not for each team, but for each person. So yes, you can take your votes, you can change it, but the last time that you made will be saved when we close the voting part. So are you excited? I cannot see any excited faces. You are, right? Oh, yes. Okay. So I would like to tell a couple of things. It was really nice to have you here, some of you again, even at Code Like a Bosch or just at the hackathon or at this venue. I hope you enjoyed every part of the hackathon, and I would also like to ask thanks to the mentors and the juries that they were here with us, supported you, and hopefully gave a lot of good advices and feedback. I would like to thank the CraftHub team for making this event happen, and also the Bosch in overall, that we could organize the third hackathon to you. And I hope that you will come back to us for another event as well. And yes, we are still having 2 minutes. And I think that this is the time to ask someone from Bosch to actually make a closing speech. Yes. The one who made a lot of questions. Okay.
Guys, what an event. I was super excited to join you before this whole hackathon started, and I was just standing here, and then I saw the numbers that 532 people from 52 countries. I got goosebumps, to be honest. It's like how I can mentor so many people. I'm super tired. I had 4 hours of sleep, so I cannot even imagine how you guys are currently handling the no sleep day. So I'm trying to be fast and quick. A personal story why I think developing these functionalities are good. I used to be a developer actually. And my code was in a vehicle. And it was a normal Wednesday drinking coffee in the office, and I got a call from our customer like, hey David, we must talk. All gentlemen arrived to the dealership and he said thank you. And I was like, oh, why? He was driving on a highway with high velocity and he was tired and not attentive. And that was almost a severe accident. And the car braked. And the guy was coming back to the dealership that, hey, I would like to thank to the guys who developed this functionality. So as a message, I really hope that you will have the same experience and be so proud for your work later on, because what I saw on today's on the software, those were really good projects. So even to make the call for the challenge was really hard, and congratulations for everybody. It was a fantastic event, and I hope to see you, work with you in the future soon. So thank you very much, guys.
Thank you, and I think that we closed the voting, right? Did we close it? Yes, so in a few seconds we will have the grand winner. But in the meantime, I think that we can announce the challenge winners itself. So I'm not sure which one of you will hand them over to the teams, but I would like to ask one person from the hardware and one from the software challenge. István, would you like to? Yes, he's coming. But firstly, the software challenge. So I'm giving you the prices. Yes.
So, guys, just one moment.
Sorry, technical problems. I would vote to have first the hardware challenge. I think we should give the hardware challenge first.
So, István, please. This is right.
Yeah, this is the problem. The software always has some bugs. That's why. You're welcome. So I would like to ask the guys with the funny name and the good demo to the stage. So I would like to announce that the hardware challenge was won by Project Furfang. Come to the stage, guys. Let's hope the software has the answers right now.
Thank you. And now the software winner.
Sorry guys, looks like the 4-hour sleep got me. And please don't use the same names, it got confused me. So the winner of the software challenge really had to head with the other teams, but it's Crash Like a Bosch. Thank you. Congratulations.
Thank you. And congratulate the teams. Let's see if one of you will take home the grand prize as well, or another team will take home that 5,000 euros. So I've got the message, but I want to make sure that I will, or Attila, do you want to hand over the grand prize? Yes. And it has arrived.
So yes, I want to hand over the grand prize. I'm always happy to do so. So the winner of the grand prize is AR Set. Congratulations. Are you guys here? Then just come and... Okay. Congratulations and a big applause to the winner.
What will you do with that 5,000 euro?
I will buy an old Audi.
Such a nice answer. And you?
Maybe buy a motorbike.
But I hope that you will use only Bosch tools to prepare it. Okay. Thank you guys. Congrats. And before you would leave the stage, I would like to ask everyone to come to the stage, even the Bosch mentors and juries, to take a group photo, to make a memory with you that you were here with us this time as well. Come to the stage. I won't leave you until you do so. Also, the CraftHub staff, please. And do not leave after the photo, because we will also announce the winner of the CraftHub game, who won the Compass Tech Summit ticket. If you listen to me, I can say it right now. So we have two winners, Christian Bertalan and Akshan Kipayat Nirpo. I'm sorry. Oh, yes. So we will send you an email with the tickets, okay, guys? And please come on the stage. Why are you standing backwards? Come. Yes, you can sit there, but please be aware of the streamer phone. Yes, come. I will close the doors until we have these photos, so please come to the stage. You were the part of it. Yes, you can, I can see some empty spaces still, so you can even, like, yes, sit in front of the first line, go to the back, guys. You can go inside. Do not be shy. You were here the whole weekend. It is your time to make a memory. Come. Yes. Girls, go inside, go in front of the guys. Yeah. We will Photoshop the rest of the people, and that won't be that fun. Say cheese. Or hackathon. Bye. Okay. Thank you, everyone. Hope that we will meet you at our next hackathon as well. I would have one last question. Raise your hand if you will join us at the next Code Like a Bosch hackathon. Raise your hands. Yay, nice. Then I hope that we will organize another one, a fourth one. Okay. Have a nice weekend. See you soon, and have some rest, guys. You made a great job. Thank you.